Welcome, guys. Welcome to the animated Up-sskill Club. It's season 3, episode number 7. Focus for season 3 has been system design. We are learning from a very famous author. Will not name him for credit's sake, so that he cannot charge us money. But we can read his work and talk about it. So today we'll discuss how do you design a chat system. Uh, for people who have been to this series, for every system design, one of the primary things what you need to take care of is what are the basic requirements. What are you actually designing for? So those are the things which we'll discuss at first. The requirements for this chat system that we will discuss is it should support one-on-one and group chat. And this is nothing new. That's why I'm not explaining the trivial thing, because we all use chat system on a daily basis, be it WhatsApp, Snapchat, Manish likes Facebook Messenger. So all those things are used on a daily capacity by all of us. Telegram is also one, and that's my personal favorite. But all of these things happens. It is not. So we are. If you talk about pure in terms of time, if you ask anybody what is the maximum amount of time you spend on your mobile phone and which application, the application name is not Snapchat, is not WhatsApp, it is actually keyboard. You spend 50% of your time right typing something, and more than the 30% of time on these communication apps at least. So it would be good learning for all of us to understand how they work internet. The requirement for the system that we'll discuss is it should be a one-on-one chat, and it should also support group chat. Manish has something to comment. Not me. Okay.
आपकी voice break हो
My voice is breaking. So give me a second. Give me a second. Let me switch to a different Wi-Fi. I don't know. Is it still breaking?
A bit fine on last one.
I'm switching to a different network. I haven't switched yet. Let me pause. Thanks. So okay, let's keep aside the internet issue. Let's revisit the requirements. Aman has also joined. Okay, Aman. Welcome to yet another episode. There are some rules for this session. You need to enable avatar very quick. We literally checked for Mukul. The experiment has not been made live for him. So you need to enable avatars for yourself so that you can attend this session. If you don't, I'm sorry, you're not needed. Go to your video section. Go to your video section and enable it. Okay, we'll continue with the session, but if you're not able to turn on your avatars by 4:25, maybe we'll see you in the next episode. Aman. Okay, so we are discussing the requirement of our chat system. First, it should support one-on-one. It should be a group. It should also support a group chat. It should be a mobile app, and it should also be a web app. And no more bias. #Orion. It should support at least 50 million daily active users. That is the scale it should support. For a group chat, at maximum, it should allow 100 people to chat concurrently. In online and group chat, it should have an online indicator. Hey, somebody is online who is not online. For now, it should only support text messages. So we're not talking about PDFs, images, videos, MMS. So we're not talking about those. Okay. So no fun. It's only chat. A text length for a single message should at max be 103, 1 lakh character long. Okay. Is end-to-end encryption required? Let's skip it for the first version. We don't need it for now, per se. Who has privacy on internet anyway? How long should you preserve your chat? It should be always. So a small reminder for Aman, you only have 60 seconds left.
Well, how to do that? Can you tell me in the video section where to go? I'm just finding that out.
Harsh has posted a screenshot. You can refer that as a reference point in our common chat channel.
Video filters, got it.
Okay. So next,
getting that actually that option the Harsh had shared.
Then it's okay. then you can attend. So do you need to support multiple devices? Yes, a same device can be logged on multiple devices. Do you need to support push notifications? Yes. So any questions till now for requirements? Mukul, would you like to just repeat requirements for everybody?
Yeah, sure. So basically, there should be mobile and web app, like it should be enabled on all the devices. Okay. The chat should be for one-on-one as well as the group chat. Okay, so but on the group chat there should be maximum of 100 people that should be connected. Okay, and the messages should remain for all time. Okay, end-to-end encryption for now we can keep it aside, but for future it's needed. Okay, and all the history and the media should be we will be able to download it, and like there is a maximum length of 100 something characters, like that should be there.
1 lakh.
1 lakh characters. Sorry, I didn't got the exact.
I hope requirements is clear to everybody. So before we deep dive into, let's say, design, some general commentary. We all know server and application, how does server and application communication works, right? Okay. In a standard chat system, let's say, be it on web or mobile, clients, which is you and me, right now, let's take an example of Zoom. If I write a chat message, literally, if I take example of chat messaging of Zoom, if I type something, it is not directly sent to you. It goes to the networking server of Zoom, then it is relayed to you. Okay, the message is relayed to all five people. The P2P communication doesn't happen in chat design, never. And a file transformation, all that happens. P2P communication for chat doesn't happen if the central is centralized. Okay, there is no decentralized chat system per se. You can think about it, but it will only work. It will only have 2 users in that case. Cool. So for any logical chat system, there will always be 2 people, 3 people. Sorry, one sender, as you can see in the example, he sends a message. Then there will be a chat service or chat system, which will either it will store message for the time being. Why does it need to store? Because not necessarily the receiver will be online. So for the time being, he will need to store it. Then only propagate the message when customer is online. When will that be use case? Let's say you uninstall your WhatsApp and you come after, let's say, a month, like I used to do for years. Then I used to get bombarded with thousands of messages then and there. Correct? Because WhatsApp was storing those messages. And yes, it will have some TTL. I am not saying they are storing message forever. They will have some TTL. I'll get 6 month long messages. If anybody has sent me any message, if I didn't had WhatsApp for 6 months, I'll receive those messages. So that happens. That's why I need to store messages, and relay messages is concurrent. You send a message, immediately you see a blue tick. Why? That message was delivered to the expected party. Correct? This is how a traditional design works at very, very high level. Okay. Now, in terms of protocol, client to server protocol is actually very standardized. It is standardized to the level of entire internet. Everybody uses HTTP. Okay, everybody uses HTTP. Get, post, all those are, let's say, the sub flavors of it. But everybody uses HTTP protocol to use the port to communicate for all the messages through packets on web. So client to server system is standardized. So we can use HTTP protocol per se. There is no problem with that. Okay, because it's a client, because client triggers the communication. How does that happens for a chat system? When you press that send button, that's why you have send button every single time. The moment you send that button, that is a trigger which is triggered, and you receive the incoming message in the chat server, and then it can be further relayed. So that's clear, correct? Receiver side is actually a little bit complicated because HTTP is client initiated. A receiver cannot initiate a message every single time. Hey, send me messages. Hey, send me a message. It can. We'll talk about those also. So there have been various solutions to it. First is polling, very traditional. Receiver continuously asks, hey, do I? As you can see from the design, the first is polling, where receiver says, in this case, it is client. The receiver says, hey, do I have any new messages? Server says, no, you don't. The connection is closed. Then you keep asking after 5 minutes. Let's say every 5 minutes, or for a small window or a period of time, you keep asking your server, hey, do I have any messages? Server either gives you the message or it doesn't. As simple as that. Fair enough? Simple design, but it doesn't work. Because not only it drains battery, unnecessary HTTP call, it's just a very substandard design as overall because of those reasons. So people evolved from polling to long polling, which is just make the progression longer. You know, because polling is inefficient, let's just wait for a decent amount of time. So you received a message, server doesn't respond to you immediately. It waits for some time before reverting back, and it waits for that period on the backend, then only returns back, and this cycle goes on. It also happens is collection is maintained for a probability or threshold of time. In polling, connection was closed immediately. You sent a request and you receive a response, and the connection was either you receive a new message, or irrespective of you received or you didn't receive, the connection was closed. In long polling, you keep it open for a certain period of time. That's the only difference between long polling and a polling. Cool. It also has a decent amount of limitations. There is just no way to tell if client was actually disconnected, if he is even there to receive the message. You know, and if a user doesn't chat much, imagine long polling was implemented at Facebook scale. People are not chatting because very few people do at a single time, because you need to maintain a long channel, a long polling threshold. You'll be wasting decent amount of resources on both the end. Correct. And there will be very frequent timeouts for these set of users. So it was just not optimal. So then people realize something else, which is very standard. Then how HTTP is a very standard protocol. When server wants to, a client wants to trigger something, the new protocol, which is WebSocket, is very standard. When client doesn't want to trigger something, server wants to create a very concurrent communication between server and client. So WebSocket is the most used protocol currently. Example, client sends a, this is a traditional transaction in WebSocket. A client sends a HTTP handshake request. Handshake request was received. And then there is a probability of bidirectional messages. Client can also send messages, server can also send messages. Very simple. Cool. So after handshake is complete, now you guys can send each other messages whenever you want to. So if server has received a new message which needs to be relayed, it doesn't need to wait for, let's say, validation, because it knows it can send message to the client, which it has maintained. It can send it immediately. And because WebSocket uses the standard port of 80 and 443, the behavior is also very similar for HTTPS. It also uses 80 and 443. And it also doesn't get blocked by various firewalls unnecessarily. So it's very standard. Any question? I guess I have everybody. Achha, yes. So Manisha just said yes. I don't know if he was confirming to something, but.
So tell me I'm right. I think that you are saying that the client and the server, for them both, the sender and the receiver, made a bidirectional messages communication, right? Got it.
Then now author makes an interesting observation, which is if WebSocket is bidirectional and if you have agreed to use it for the receiver end, why not use it for sender end also? Fair enough. Fair point from the author. He suggests to just create a handshake with all your clients, which is either they are sender or receivers through WebSocket only, so that you can send bidirectional messages. Predominantly in the cases of senders, you will receive chat service will receive the message and receivers will receive the message. But when receiver becomes a sender, you don't have to do anything special for the sender in the first case, which will become a receiver. So the same connection will work. So that's why WebSocket fits beautifully in all the chat systems worldwide. Fair enough. So any questions till now? Aman, would you like to summarize polling, long polling, and WebSocket, whatever your interpretation was?
Sure. So polling was just like a polling mechanism in which a receiver just asks the server, is there any new messages? And if he said if there replies with a new message or it doesn't send a new message, then the connection gets closed. And it is a very overwhelming situation because client keeps on pulling and it is not a, you can say, feasible design for the system. Then there came solution for long polling. Long polling means that the connection was not closed, only the duration was become longer. So at both of the end, there are two things. You are wasting the resources of the servers and the client, and there's no way to confirm that the client gets disconnected. That's what I have heard in this meeting. And then the third one was the WebSockets, in which you just have a handshake with the server. That both of them can receive the messages. Both of them, there's a bidirectional communication with either server or either sender can send the messages. And that was the thing. But post that, we just seen that the server will do this type of WebSocket connection with all of the client. So ultimately, all of the client becomes the sender and the receiver as well. That's what I have concluded.
Fair enough. So let's continue further. So now we'll deep dive into overall design. Then we have learned how we'll be communicating. Now let's talk about the overall high level design. So what author has suggested is we need to divide our entire design into three parts. First is the stateless part. And stateless part is predominantly used for the trivial things, because even for WhatsApp or any other let's say server, any other system, you need a user, correct? You need a group management who all are part of that group. You need an authentication service which says, hey, is this user allowed or not? Has he expired? His token has expired. And overall service discovery, what are the offerings of the systems are, stories and all that needs to be there, correct? Apart from the central chat system. So that is a stateless system. It will work very closely how you see infra works, which is you come, the request is received. Hey, I want to create an ID on, let's say, WhatsApp. It will be redirected to user profile service. User profile service will create its user and return back with the user ID and the token, and the profile will be created. This will be pure stateless design of any transactional marketplace, chat system, e-commerce. For all of them, this is very same. Then there is stateful. Stateful, as we
sorry, Anupam, so what is the stateless here refers to?
Stateless is whenever you are interacting with the system. Let's say when a request is received from a client, correct? A client can send create profile 10 times, correct? Technically, user profile doesn't know what happened with the last request. It doesn't remember a particular client state. It is a purely a transactional system. You give me a request, I'll give you a response. I'm not remembering, hey, to make it more relatable for you particularly, Aman, let's say order was placed. An order goes to multiple states, right? It was placed, it was fulfilled, and before that, and job startup, everything happens, correct? So the request which is coming in, the container that your code is deployed, doesn't know, okay, hey, what happened for this user when last time he hit. So it doesn't matter to which container your request is fanned out to from the load balancer. Every single instance of the user profile service will be able to cater to your service. But if it was stateful, container would need to create a mapping internally, the state, hey, what happened with the last request, and I can only respond accordingly. Because it's a stateless design, it doesn't matter which container serves your request. Every single let's say a container user profile code on any container will revert back with the right response. It doesn't matter.
And response will be the same. If the
response will be the same.
Always got it.
Manish has added a couple of points, which is all data is sent in every request. All requests are independent for all these flows. Yes, no sessioning is no session. There is just no session information. Example, if you talk about UC system, it becomes tricky for our CPRS system because it tries to maintain a couple of session level information. Cool. So it becomes tricky for CPRS system, but for a pure profile system, it doesn't matter. It doesn't matter from which container you're creating profile, and which container you are editing profile. Just there is no session involved. This is clear. This is very standard for all software actually backend design out there. E-commerce, marketplace, content based, chat system. This doesn't matter. These system needs to be stateless. As we learned earlier, if you are creating let's say a concurrent connection through WebSocket, you will remember that connection, right? And if you want to do it, the second part, which is stateful system, which is people call it proxy server, people call it chat service, whatever you name it, whatever you want, you will remember the channel, which is if there is an IP that you internally have, there is an IP that the client has. And I have created a mapping and I have created a handshake on this IP and this IP through WebSocket protocol. So I need to remember the IP that I have, and I need to remember the IP the client have. Hence, this connection needs to be maintained. If the connection is maintained for a duration of, let's say, to send send packages, to send chat messages, this you are remembering the state, correct? Now, this chat service, if deployed on a new container, if doesn't has the handshake enabled, it will not be able to send let's say chat messages. So this becomes a stateful system. This is clear also, Aman?
Got it.
Cool. And then there is third party system. You missed push notification is very standardized. I didn't cover it because it is very standardized. Either you go to APNS system for Apple or FCM system for Google for Android predominantly, and you create one more layer on top of it to get user profile information, get GSM token or APNS token, and forward the message in a very standard template form to either APNS or either FCMs that those notifications are received. So this is a third party system in the chat system. This is what was discussed. The last part is the scalability. Scalability, author says, because we are for the scale that we are discussing, and even if you have 1 million concurrent users out of 50 million daily active users, if you have 1 million concurrent users and all of them consume 10K bits memory on the server, and on the server, you would only need 10 GB of memory on every single box. On every single box, even if you hit concurrent 1 million concurrent users. He says for the sake of this discussion, single server design is okay. Okay, everything is hosted on one single server. This means your system is not distributed. He's not talking about everything is distributed apart from the base layers. So this is how he suggests user sends a request. It is received, HTTP request is received by load balancer. Load balancer forwards to corresponding API servers, and API servers send the notification, and we will talk about KV stores later. KV store is key value stores. And then there is another system which is stateless system, which is talking through WebSocket. This is a real-time service. It has chat service and presence server. Presence servers are different from chat servers. Chat servers' responsibility is to store and relay message. Presence server is responsibility is to, hey, who is online? Display that status. Okay. This is the high-level design of the system that we have discussed till now. To summarize, clients maintains let's say a concurrent connection with the backend through WebSocket. Client servers facilitate sending and receiving. Presence servers solves for online and offline status. API server solve for all the stateless requirements. Notification system solves for the third-party requirement of sending notification through APNS or FCM. And finally, a key value store, which is to store your chat history. Because if you remember, one of the requirements, for how long we wanted to store the chat history?
Forever, I guess, right?
Forever.
Lifetime.
We wanted to store it for forever. And we wanted to show the design.
I think you said for the, I think, unseen messages you are storing for 6 months, I think.
No, that was an example I gave for myself, for WhatsApp, what happened to me. For requirements sake, we will discuss it forever. Okay. Let's talk about the raw database. From what author has suggested, there is no direct answer for it. Okay, there is no direct answer for it because if you talk about the current scale, and if we try to map it through Facebook and let's say WhatsApp, at their scale they receive around 60 to 70 billion messages a day. 60 to 70 billion entries needs to be made on the system. So this is a very heavy write pattern, correct? And similarly, there is a very heavy read pattern also. So till now, what we have learned, if you remember all our previous discussions, some particular kind of database was optimized for structural reads, and particular kind of database was optimized for structural writes, correct? And we traditionally prefer, hey, if your requirement is write heavy, and you want to remember that, go for SQL. But if your requirement is read heavy, go for Mongo, correct? That has been our learning. But in our chat systems, both will be heavy. It is almost 1:1. Almost every message in terms of pure numbers, same amount of messages will be read, same amount of messages will be sent, because literally you are sending something, it has to be read by somebody else. Correct? So there is very close one-on-one mapping. So your system is read heavy and write heavy also. So this is one of the unique requirement for a chat system. Key value stores. So for a stateless requirement, you can use, author says, you can use a very typical SQL system, or you can choose no SQL. There is no choice about it. You can choose whatever you're comfortable with. They will work fine. For purely for read purposes, he suggests to go for a key value store. Mongo is one, Cassandra is one, HBase is one, Bigtable is one. There are various. All of the large scale systems are actually key value store. They're not relational. They are not relational. Key value stores handle scaling, horizontal scaling well. In terms of pure complexity, they handle low level. They give you low latency in terms of access data, because a lot of entries will be made, and from a relational point of view, indexing is limited. Indexing is limited to quick query to, let's say, a very random information. Example, you can search for anything in chat that you have typed, correct? Anything, you can literally search for any keyword. So in order to create an index, it is almost impossible, because even if you type gibberish on WhatsApp, it will be searched very fast. How does that happen? Because almost everything is indexed. So in a relational database, everything cannot be indexed. That is the database. You cannot index the entire database, correct? So that's why key value stores are better optimized for a low level latency to access any kind of data, even the long tail of data. Okay. And random access is not that expensive in key value store. In relational, it is relatively heavy. That's why he suggests sorry, to use key value data stores. Cool. Harsh, would you like to summarize whatever we have read till now, and any questions do you have?
Sure. So, just recalling what we have studied, please add if I missed. So, I think we started with stateless and non-stateless, where basically some information that we were storing were in a stateless fashion, like profile and some API servers that were needed. And apart from that, there were some connections to WebSockets, which we discussed that how there was a present server, which was maintaining details about whether the user is online or not, and a chat servers, which were keeping to a KV store. Then we went into I guess database design, then like how data was getting stored. So like we had discussed about that the data is very huge for the users. Um, so maintaining a relational database was not feasible because there were like 60 billion messages per day that we discussed. So we were using kind of a KV store to store our chat, since we have to store it forever. And indexing was also easy, that like Anupam said, because huge data will be there and we need to do a lot of indexing to search and things like that. So these things I think we had discussed.
Okay.
Can you repeat the the indexing part? You were saying that you have too many messages, you can't have an index on every field in SQL. On Mongo, you said indexing is possible on everything.
It's not possible indexing on anything. The low level access to the cost that you will pay in terms of query on Mongo to access something which is not indexed is lower than cost of something that you will pay on a relational database. That's it. Manish is the expert here. Manish, do you have anything else to add? Purely in terms of
I think more or less the idea is that which database is optimized for like searching, and like Mongo is obviously more proficient than MySQL in that regard. That's like the major point. Yeah.
yes, nothing special. It's like the relational database cost of creating an index in relational database is even higher. Updating is even higher, because in a chat system, if you want to search for anything in chat, example, I can literally type this in my chat and send it to you, right? Let's say right now, let me do that. I just copied it and pasted it, correct? Now if there was a search, I don't know if there is a search here. If you want to search something as created ad as a string, it will be written fairly very easily. But if this was let's say a relational database, imagine what index that you will create. Will you create entire string as index? And no. Would you go and divide the chat messages into multiple parts and then store them as independent formats? No. Easier value is create tokens, as Manisha suggested, and search for tokens. Cool. Just power them in Elasticsearch, and Elasticsearch will just search very quickly on top of it. You can do that similarly. You can do that the same for relational database also. It's not like that you cannot do that. It can fairly be done, but Mongo is by design optimized for it. That's about it. It's designed to be more let's say adaptable for read-based queries, read-based systems. So Elasticsearch is the best.
Right.
Elasticsearch is the best. Then Mongo, then MySQL. Correct. Mongo
Yeah,
by design also supports a good text search, but you can create system where you're reading through various things and creating tokens and creating a mapping of the message that you want to, let's say, highlight it and get that message ID and then fetch that message. You can do that, but Mongo is better suited to support the read-based systems.
one thing, like you mentioned, Elasticsearch is used for searching the part that we do in WhatsApp and search the particular keyword like created at. Okay. Now, at the scale of Facebook and WhatsApp, as you mentioned, like there are 60 billion messages per day. Okay. They are creating the tokens of all of them like regularly. The cost will be huge now.
It doesn't matter. No, that doesn't limits our design, but that is not what we are discussing. The cost can be there, but if you're talking cost in terms of iterating, then we should discuss. But in terms of pure infra cost, I don't think it matters to them. Amanisha suggested something else, maintaining. Yes, sharding bhi hogi, yes.
Sharding to direct
At Facebook level, there will be obviously sharding. We haven't seen any system of that scale, so hence we cannot say from experience.
I think I remember the time. I think somewhere around when Instagram was not big and WhatsApp was just there. So like back when we used to have Facebook. So what I would try to do is I would try to go back in time in chats, and it was relatively hard. What they would do is they will make you click on see older messages, and like basically what they're saying is they really optimize your recent messages, but like if you have to go back, it is harder. And I think potentially they would be doing sharding at time level, etc., or maybe archiving, whatever they are doing. And even in search, they will not allow you to go back to that level. Like you really can't search to the first message. So sharding, I think, would be like one potential thing that they would definitely be doing, maybe at the level of time, like keep like most recent one first and like archive or shard the other ones behind. Yeah.
Cool. So let's discuss further. Now let's talk about the data models. The first on the screen that what you see is the model of a simple message. A message will simply have a message ID. Somebody will be sending this message to user ID of that guy. Somebody will receive this message to user ID of that guy. The content of the message, because we have agreed, will only send text messages. And when was this message created? Correct. There needs to be a primary ID needs to be different from created at, because we cannot rely on it, because at the same time, at the scale that we are discussing, at the exact same time, many people can send a message. Okay, so we'll not rely on it. We'll have a custom mechanism to create a message ID. When we talk about a group chat message, a group message will be different from a traditional message, because it will need to be sent to a particular group. So it can be a group ID or channel ID, it doesn't matter, but it needs to be also be created uniquely. And the entire primary key will be a combination of the group chat and the message that you have sent. Okay, and everything else stays same. You don't need a user ID here, because you are sending it to a group. Now, if we talk about message ID, if you remember one of our earlier session, we did talk about how to create a unique identifier. There was a session in a design, and the answer we landed on how Snowflake goes about it by dividing the entire message into 4 parts, using timestamp, then using the container that you have hit, the entire node that you have hit, then the container that you have hit, at the timestamp that you have hit, and then a random number at the last. That is how Snowflake goes about it for creating its entire sequence. You can use an auto increment because we have chosen a key value store. It doesn't have that by design. You can hack it around. There are add-ons that you can use to have an auto increment system. Mongo also gives you a very decent object ID whenever you are creating a new record. It also gives you that. You can use that also. But at the final level, what author suggests is use a local sequence number generator. Local sequence number generator predominantly focuses on because the local ID will be unique for that message at the level of a group. So that's okay. Because when you're maintaining a, let's say, uniqueness at a group level, it's okay. You don't need it to be globally unique. When you have set a message and it is very very unique for that particular group, if it is unique for that group, it's okay. If it's something else come out for any other group and it matches with that group, it's okay. That is what author suggests. कुछ लिखा है इसमें. हाँ, auto increment doesn't works at a distributed level. We have learned that. We have also learned that even हाँ.
I think it may have one thing, right? If you, what happen if you have a same, you can say ID for the two groups messages?
You can't, right? Because
नहीं.
timestamp itself
लोकल आईडी
is
पे जा रहे हैं ना, तो तुम प्लेटफॉर्म किस कंटेनर को हिट कर रहे हो, किस चैनल को हिट कर रहे हो, किस ग्रुप पे जा रहे हो, ये सब लोकल आईडी मतलब उस कंटेनर के हिट पे डिसाइड हो रहा है. दैट्स इट. इट मींस कि जब वो हिट आई जिस कंटेनर की इंस्टेंस पे, उस पॉइंट पे डिसाइड होके तुम्हारे डेटाबेस में चला जा रहा है. और उसमें क्लाइंट आईडी एक आइडेंटिफायर फॉर let's say the system that you have hit, the node that you have hit, the container instance that you have hit, the timestamp that you have hit, and at last a small random identifier that you don't want to expose is exposed. कुछ और भी लिखा है. हाँ, nanosecond, and this is very 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 once in 10-20 trillion years में collision होगा. इस लेवल की probability पे हो रहा है. Fair enough? ठीक. So this is simple about message ID. So then service discovery is basically आपका system बहुत distributed होगा, and zookeeper is nothing new. When a user tries to log in, ठीक है, load balancer will send a request to API servers, correct? After the backend authenticates the user, service discovery finds the best chat server for a user because multiple instances of chat servers will be created, correct? And server 2, why is this important? Because chat servers are stateful, not state. Yes, they are stateful. So there needs to be a zookeeper or somebody who maintains this record. Hey, this user came in simple map, which server he was allotted to. This is very simple. This is clear. Aman has some.
How we are building fail-safe here, whatever server down. So you have a. I'm saying what there will be a replica of that server level, right? Master slave architecture also being there. What happens if the master server goes on for that particular best server which you have found? The content has to.
Fail-safe mechanism will be at two levels. First, there will be consistent hashing ring to allot the server so that load is balanced. That is first level. Ki, haan, bhai, extra load, nobody becomes a hotkey. That is one level number one. And you will always have the master slave configuration. Hey, if the main master goes down, chat server, let's say n plus, let's say n minus 2, there will be n minus 2 copy 1 and 2 copy 2 ready, and based upon the scale that you people have. If you are at a very small scale, you will only have 2 chat servers and you will have 2 backups for them. But if you are at the scale of, let's say, Facebook, WhatsApp, you will have n number of chat servers with couple of at least couple of backups, and we have covered those in our previous session. How should you go about it? How should the write be synchronous? The relay to these slave servers should those be synchronous or should those be asynchronous? We have covered that in our previous sessions. But this is clear how why this needs to why do you even need a zookeeper? Because our just client to server communication purely for the WebSocket communication that you want to create is not stateless, it is stateful. Cool. That's why you need a zookeeper. Cool. Then let's talk about the top level design for a one-on-one message. Sorry. Manish, would you like to give a commentary from whatever you are currently inferring from this design?
From this one.
Whatever comes to your mind, you can just give a dump.
I think in this design, I mean, I don't know if there's something new that I can add that is not already on the screen, but more or less that a couple of things that I would note which are important. I think they're already boxed in some way. One is that ID generator that we have already discussed, how those IDs are unique, because that is very important, but like there's a good process behind it. Then the second thing that you can see is, of course, there's a message sync queue. That is important because like messages in the order in which they're going in, that all matters a lot. Like if they get messed up, it can, and it has to be like a queue mechanism. Then KV store is the part that we have already discussed, how that is the most relevant database for the requirement because we have heavy read and write.
And this is new. The 5A and 5B is actually new. This is the new server. Now you need to take a look. Chat server 1 is different from chat server 2. That is the first observation that you should make. The state is maintained but on different chat servers. That is first. And if user is online, the message is relayed immediately. If it is not online, is offline, message is stored.
Yeah, need push notification servers, right?
Yes. But people do that in various shape and form. WhatsApp maintains, uses the WebSocket only to send these messages and renders its UI, because push notifications have a limitation of, you might have observed UC's notifications are only received, let's say 30% of time. WhatsApp is received every single time. Right? How does that happen? Because WhatsApp leverages WebSocket only to send push notifications. We don't. We rely on third party. This is clear for everybody. Only two things new to observe in this design, which is chat server 1 and chat server 2 are different, because Zookeeper can assign, Zookeeper might have assigned user A some n server and user B n by 2 server. It can differ. But after before the message has to be sent, you will go to Zookeeper, ask him, hey, I want to send a message to user number, where should I go? He says to chat server 2, but you should only go there if user is online. If he's not online, just push that message in the let's say present servers. Okay, fair enough. Let's move ahead. So this was about and as author has suggested a couple of things, which is when user and A and B are connected, you can send concurrent messages then and there. That you might have observed, right? You don't receive push notifications when you are actually chatting with somebody. You only receive them when your state of your app is in background or killed. Correct? Not getting it? Correct?
Yeah.
So that's about it. If user was online, either you can send a push notification directly and store them. If user is not online, or if user is offline for very long, you will store them first before directly sending out a push notification, because it will get wasted. As I said earlier with my example, I installed WhatsApp after 6 months. So those messages were held up. Then they were all bombarded to my phone through push notifications. Then let's talk about so there will be problem of synchronization across multiple devices. Okay, this is a very subset of the problem, because you will have user, as you can see, there's user A, and user A has two identities: message ID 1, message ID 2. User A is logged on to chat server 1 through laptop and chat server 2 to phone. User this is marrying his existing stateful information with his profile and then updating the same store against him in the raw database, so that he doesn't see two messages. Once you identify, hey, this is just a different device, Zookeeper needs to understand, hey, this is a different device, but this belongs to a same user. He should be going to the same server, and same server will identify, hey, this is the same user. It needs to go through the same user ID, because he will enter use the same message set of messages stored in the database, and this is how they are maintained.
Is it kind of a list of socket, right? That would be connected, user A would be connected to.
Not clear.
I'm just thinking, like someone user is connected from phone and also connected from laptop, right? So like we had discussed, it would be maintaining a stateful information in Zookeeper that user is connected over these sockets, right? So my question is, it would be like kind of an array of sockets that the user is connected to, and we need to send messages to each of the socket, right?
Correct, but only I have not discussed this, sorry, but if you see that one critical identifier is maintained at every user level. What is the maximum number of messages that you have read? What was the last identifier? So there is a versioning of, let's say, your own state of information which is happening. Let's say user A, you have sent a message and interacted with your significant other, and you have transaction for 100 messages, and you skipped your phone. Then you move to your laptop and you did that, correct, for 100 other messages. So your phone has only read the first 100 messages, so its identifier will, let's say, will become 100. On your laptop it will become 200, because it will receive the first 100 messages, then you will send 100 more. Now when you switch back to your phone, how would the system identify, hey, how much message this guy needs to know, needs to be sent to this guy again? Correct? You will get the last identifier, which is 100, and then you will send the delta 100 to 200. That's
Harsh,
how.
you can even try this. So if you use WhatsApp web along with your phone, what will automatically happen is, and if you leave your WhatsApp web on the side, and you start chatting on your phone, the moment you come back on WhatsApp web, first you will see you have to like you will get as unread messages all those messages you have done on your phone, because the system is trying to sync all
Yeah.
the messages, and like that's what Anupam was talking about. That since the same user is making two messages, but they are session differently on two devices, they need to sync at some point.
That's right. Got it.
Hmm. Aman, you have something.
Uh, you said that if a user's device got changed, it has to be mapped to the same chat server, right? So what will happen, matlab, if the chat server has also ability that it has maintaining some users and someone came that I am belong to this. So how will that will be managed? So how they are managing two users at the same chat server?
How will every
Well, how will chat server manage users, two user for, you can say two devices, you said, na, two devices for the same user.
so if you talk in terms of pure HTTP, let's go back in our original design. Let's come here. Okay, no, not here. Let's come here. You're saying this is user A, user B. You will log in from this device. You will also log in from this device. Correct. You will do your user management on land on various skin, and you will get user ID in return. Correct. You will land on Zookeeper first. Zookeeper will get device ID and profile ID. Correct. Device ID and profile ID. Zookeeper will identify, hey, this both of these two IDs belong to one single profile ID. They both needs to be maintained either on same server or on another server, preferably on same server. Preferably,
Yeah.
but actually doesn't matter. You can go to any other server also, because the state management is also inbuilt in terms of the message syncing in terms of last message that was read by you. There is no direct need to be allotted to the same server. You can be allotted to different server, in my opinion. There is no necessity to be for you to be allotted to the same server.
Got it.
They can do that to optimize, let's say, frequency of connection, all that. I don't know, I'm not the expert there, but in my opinion, you can be allotted to any different server, because what is the message that you have read is identified from a very different identifier. What is the current max ID? Cool. Let's move ahead. Now this is somebody has said something. Got it. Okay. Then now we have talked about one-on-one messages. I believe we have fairly decent idea how the message syncing is working and how the message is sent. Now this will become interesting. This is where your difference of opinion, in my opinion, will come from author in some shape and form. So let's consume this design. Let's talk about whatever you want. You are current. Harsh, you can go ahead and you can talk about whatever you are currently inferring from this design.
Sure. So user is sending to the chat server. User is sending a message in the group, and chat server will receive that from the WebSocket, which the user is connected to, and there would be multiple message queues. Like we need.
Why do you need multiple messages queue? This is where it will become interesting.
Right. Maybe for different chat servers which
Harsh,
we want to send to.
I just want to highlight this is not multiple messaging queue. These are multiple message sync queue going to different users.
Okay. Right. Like we are writing to the message queue, and it's basically sending the messages to the users who are part of that group.
Correct. Let me just quickly read the commentary by the author also. Okay. A user A sends a message in the group chat. Okay. Assume there are only three members in the group, A, B, and C. Okay. First, the message from user A is copied to each group member's message sync queue. Okay. One for user B and second for user A. There are two copies of the message that A has sent. You can think of message sync queue as an inbox of recipient. So you can see every single person has an independent inbox. This is clear now. This is how this is different from the earlier message queue that we discussed. This is at a user level. Once a message is received, actually there's more around a business logic here, and this is maintained for every single user independently. Aman, you don't look very happy with this design.
I didn't understand the first one. The second one makes sense, but the first one is I didn't clear what is that.
This is one. So after a message is received here, it will be sent to message queue, right? Now we are
Okay.
learning actually a message queue is maintained at a user level for to whom you are trying to send it. If the message was one-on-one, it will be sent to that particular group's message queue, messaging queue. But if you have sent a group message, and let's say you had 100 messages, 100 people in that group, 100 message sync queues for those 100 users will get let's say will be updated by one new message. Here, this representation is simply this message, this current representation signifies that there was only one message queue, and every single message received from any number of users on the chat server one will be added to it. Correct? But after that is done, before it needs to be propagated, it will also enter a user level message queue. Or you actually don't need it here. You can only have n number of queues for n number of users. This design, as the author says, works well when you have very small set of group, 100 to 100. WeChat currently uses this design because they have a limitation of 500 people in a group, and their infra can maintain 500 message sync queues. Cool. So every message will be copied to every single queue. This design is okay when the group size is smaller, and it is not okay when the group if you expand the group size to infinite. Example, in my opinion, this design is not good for Telegram. If you have used Telegram, I hope Telegram is famous for its groups because you can have million users in groups. So if you ask, is this design good for Telegram? No. But if this design is okay for WhatsApp, who has only 256 members in a group, it is fine. This is clear now? Okay. Cool. Now let's move further. Cool. Chat C. Now, ठीक. So, as you have seen at the overall broad level, for every single user across server, only single queue is maintained. Now, to answer your second question, do we maintain these messaging copies on every single servers? No, we're maintaining them at the entire system level. Irrespective of you, from whatever you, why do you need message queue? Because obviously you need a queue because many people can send you message, many people can send you group messages, a lot of group can be updated, a lot of personal messages can be updated. So there will be one queue which will be maintained at a particular user level. Every server can add entry to it, but every single user will have independent message queue. Mukul, anything till now? Any question till now that you have?
No, not as of now.
Cool. Couple of new learnings. Let's move ahead. Now, one of the essential part of the system was online.
One question. What did we lose when we replaced multiple messaging queues to one?
What did we lose
from this design versus the design that we had above?
We lost the, let's say, time to delivery per se, because if we had multiple independent queues at every single level, if the message size was smaller, let's say 2 or 3, the message will be delivered to you faster. But if you have one queue at the top level for every single user, but you have one single queue, irrespective of you get one-on-one message, one group message, they will all be added to a queue. So there is no priority system here. Everything will be added to a queue. Even if you're very concurrently chatting with a person right now, and somebody else is posting on a let's say somebody else is posting on your group messages, your one-on-one message will get delayed for sure if you have one single queue at the entire system level.
Right. Correct. Got it.
Correct.
So हमने ये बोला कि like group level पे group level करने के लिए single queue is better, लेकिन but for one-on-one multiple queues were better.
Yes.
In that
sense. Group नहीं, for overall system cost level पे भी आ गया ना मुकुल. it is not only a matter of, let's say, design ki haan, ideal design kya hai. It is also ki what is your user base. The choice will be based on your user base. Do you have very concurrent frequent users? So if you have if your design is one-on-one chat heavy, you might prefer to have these message queues at the server level. At every single chat server will have independent message queue, and whoever message is being rallied to on that server will maintain their own queue, so that messages are delivered faster, because it is one-on-one heavy. Because group chat तो बाद में पढ़ लेते हैं, क्योंकि one-on-one जल्दी पढ़ते हैं. But if you have, but your system is not at that very scale, and let's say, and it's okay to wait for messages even for one-on-one, and let's say you are a very group heavy environment. Let's say Telegram was only focusing on groups, and one-on-one chat were less frequent. I'm just assuming. So then maintaining a top level queue will be your decent design choice, because you're compromising on now this will become an infra versus time question. Message has to be delivered very fast. Maintain a queue at independent chat server level. Message is okay to be delivered later, because one-on-one chats are less frequent on a platform. Let's have one queue at the top.
Got
Can you a little bit elaborate the top one and one? This I think little bit confusing, both of them. In that each it is maintained at a server or user level. I think it is
You are maintaining a queue ad for every user. Okay. Different in both of design. Let's say there was a chat server 1 and chat server 2. Okay. And user B and user C were there. So at chat server 1, you also have a message queue for B, and you have also a message queue for user C. Or chat server 2 also you have one more queue for user B and user C, because you are optimizing for time then. How
the time is optimizing?
Because you're sending out the communication, you're maintaining independent WebSocket communication.
Got it.
But because in our design, we are maintaining, if you remember the entire Zookeeper design earlier, we are maintaining one user connection with one particular chat server. So multiple user can send you let's say communication, but that needs to be sent by one single consumer. If you remember the design, correct? Because that connection is stateful. Hence, irrespective of 10 people, 10 independent server wants to send you messages, in this design, it is preferred to have one single message queue, and that will be maintained on the server, which is maintaining the WebSocket connection with the end user.
Got it.
See this design first, that we are maintaining one-on-one connection with the user on one chat server. So imagine chat server 1, 2, 3, and n can want to send you a server, right? User A, B, C, D, irrespective of one-on-one communication, one group communication, various people would want you to send you server, send you messages. But WebSocket connection is maintained at server number 2 only in our design.
So in that case, it has
that's why you want to have one single message queue. But this is also compromising on the fact that irrespective of whatever type of message that you are wanting to send, everybody is sent to one single queue. So even if you're chatting one-on-one somebody and you want very real-time feedback, you will see some delay, because even somebody bombards you with various group messages, your one-on-one message will get delayed, because it is purely based on probability. When was that group message was sent to any end server, and it will be received at chat server number 2, those entry will be added in your message sync, and your one-on-one message can be added at the back, and then you will receive that at a later timestamp.
मतलब थोड़ा सा इसमें कंफ्यूजन पता है क्या क्रिएट हो रही है, क्योंकि दोनों डिजाइन्स में लग रहा है कि एक यूजर लेवल पे मेंटेन हो रही है, चैट सर्वर पे मैसेज क्यों नहीं है, राइट? It was saying that
मतलब चैट सर्वर पे मैसेज क्यों है. Other option was कि do you want, ये WebSocket connection देख रहे हो आप, another option, if your chat platform was really one-on-one communication heavy, in that case don't want this design, right? Because आप message queue में add कर रहे हो और आपके net time पे आप lose कर रहे हो. तो in that case at Zookeeper level what you will say कि यार ये user ना इन set of group में added है और इन लोगों से one-on-one बात करता है, तो इन सबको एक chat server assign करो और इन सब पे copy रखो इंडिपेंडेंट मैसेज क्यू की, ताकि मैसेज जल्दी डिलीवर हो जाए.
बट इसमें थोड़ा सा इस वाले में मुझे कंफ्यूजन हो रही है, सॉरी बिटल डिले, कि इसमें जैसे कि आप कह रहे हो कि वन-ऑन-वन हैवी है इसमें, आपने कहा राइट, और इसमें चैट 2 ही सिर्फ यूजर बी के साथ कनेक्टेड है, तो जिसको भी कोई भेजना है सो दैट हैज टू बी कम्युनिकेटेड वाया चैट 2 सर्वर, राइट? चैट 1 कांट सेंड दोस if a user A want to send a message to B.
Yes.
And that message queue is in between the chat 2 server level, which it has been shown.
हाँ, मैसेज क्यू चैट 2 के लिए पास ही जाएगी यूजर नंबर 2 की।
तो ये जो मैसेज क्यों दिखा रही है किस सिस्टम लेवल पे तो नहीं, मतलब एग्जैक्टली डिजाइन में आई डोंट थिंक इट इज सेइंग कि यार कि चैट टू लेवल पे मेंटेन्ड है मैसेज क्यू।
नहीं, चैट 2 लेवल पे रखना पड़ेगा आपको, आपका वेब सॉकेट ही यहीं पर है ना।
हाँ, तो इस चैट टू सर्वर पे जितने भी होंगे फिर वो भेज देते हैं उसमें उसमें तो फिर इसमें बॉटलनेक नहीं आ जाएगी, एवरीबॉडी इज सेंडिंग द चैट टू विद द मैसेज, उसमें तो सेम चीज।
यही तो डिस्कस कर रहे थे अपन कि एवरीबॉडी टू इन ऑर्डर टू सेंड कम्युनिकेट विद यूजर बी इरिस्पेक्टिव ऑफ वन ऑन वन कम्युनिकेशन से आ रहा है, ग्रुप चैट से आ रहा है, सबको चैट सर्वर 2 पे भेजना पड़ेगा, जहां पर एक मैसेज क्यू मेंटेन है यूजर नंबर बी के लिए, सब लोग उसमें एंट्री कर रहे हैं। तो तुम टाइम पे कॉम्प्रोमाइज कर रहे हो इस डिजाइन में।
गॉट इट। और नेक्स्ट वाले में
बट अगर आपका सर्वर इमेजिन करो बहुत वन ऑन वन हैवी होता है, तुम चाहते थे कि बहुत जल्दी जाए मेरा मैसेज और प्रायोरिटी मिले, तो इफ वन ऑन वन कम्युनिकेशन वाज मेंटेन बिटवीन यूजर 1 एंड बी, तो तुम दोनों को सेम सर्वर असाइन कर दोगे और तुम एक इंडिपेंडेंट क्यू रखोगे यूजर बी के लिए, और बाकी लोगों को लेट्स से जाने दोगे वन ऑन वन मैसेज सारे इस वाले शॉर्टर क्यू से जाने दोगे, कि तुम अब वेट नहीं करोगे, तुम्हारा कोई ग्रुप मैसेज तुम्हारी डिलीवरी को पॉपुलर वो नहीं कर रहा है, एक तरह से पॉल्यूट नहीं कर रहा है इन टर्म्स ऑफ टाइम। तुम दोनों को सेम सर्वर असाइन करोगे ना, चैट सर्वर 1 ही रखोगे दोनों का और उसकी क्यू रखोगे वहां पर वो बहुत कॉस्टली डिजाइन है, बहुत बहुत कॉस्टली, क्योंकि तुम्हें बहुत कॉपीज रखनी पड़ेगी, बहुत इंडिपेंडेंट मैसेज क्यू रखनी पड़ेगी, एंड दैट ओनली मेक सेंस जब तुम्हारा सिस्टम बहुत ज्यादा वन ऑन वन हैवी हो, बहुत ज्यादा वन ऑन वन हैवी और बहुत लार्ज स्केल पे, और तुम ऑप्टिमाइज कर रहे हो टाइम के लिए। इवन दिस डिजाइन आई डोंट थिंक दैट देयर विल बी डिले ऑफ 2 और 3 एमएस का कुछ पता चलता ही नहीं है। ठीक है, दिस डिजाइन वर्क्स फाइन मेरे हिसाब से। तो ये कंफ्यूजन क्लियर है अभी यहाँ पर?
लिटिल बिट है, मुझे सेकंड वाला थोड़ा मुझे वो उसमें नहीं आ रहा है।
सेकंड वाला तो ऑथर ने सजेस्ट भी नहीं है। सेकंड वाला इज अगेन अ फ्रेगमेंट ऑफ इमेजिनेशन फ्रॉम आवर हैंड कि हाँ अगर करेंगे तो कैसे करेंगे। ऑथर ने तो सजेस्ट किया ही नहीं है, वो तो हम डिस्कस कर रहे हैं।
उसके डायग्राम्स नहीं है अभी
कुछ नहीं
बेसिकली।
वो तो हम कॉन्करेंटली डिस्कस कर रहे थे आज कि हाँ अगर वन ऑन वन के लिए ऑप्टिमाइज करना तो क्या होता।
गॉट इट। तो जितने वन वन आप एक ही चैट सर्वर पे असाइन करते हैं जितने भी यूजर्स होते हैं।
हाँ, अगर मैं अगर इसको अगर बहुत ज्यादा वन ऑन वन असाइन करता हूँ और मेरे ग्रुप मैसेज बहुत ज्यादा डिलीट कर रहा है, तो मेरा प्लेटफॉर्म इज वेरी ग्रुप हैवी, लेकिन मुझे प्रेफरेंस देनी है कि यार भाई अगर वन ऑन वन चैट हो रही है तो भाई जल्दी भेज इसको। तो क्या करता मैं, ग्रुप मैसेज तो मेरा पॉल्यूट कर रहे हैं, तो मैं उसको मूव कर देता, सब दोनों को सेम चैट सर्वर पे ले आता और उसकी इंडिपेंडेंट मैसेज क्यों रन करने लग जाता। यही ऑप्शन है मेरे पास। क्लियर है?
तो बहुत ज्यादा वो हो जाएगा ना, मल्टीपल मैसेजेस क्यों रखनी पड़ जाएंगी काफी।
यस तो कॉस्ट बहुत बढ़ जाएगी तेरे इंफ्रा की कॉस्ट है, इट हैज टू बी वर्थ इट। तो देयर इज ऑलवेज अ ट्रेड ऑफ इन डिजाइन, देयर इज ऑलवेज अ ट्रेड ऑफ, तो दिस विल बी अ ट्रेड ऑफ कि कॉस्ट बढ़ जाएगी आपकी। कूल। तो ऑनलाइन प्रेजेंस की बात कर लेते हैं। ऑनलाइन प्रेजेंस इज नॉट वेरी डिफिकल्ट, इट इज मोर अबाउट कि सर्विस आप जब टॉप लेवल पे आते हो, यू नीड टू ऐड एंड आइडेंटिफाई व्हेन वाज द यूजर लास्ट एक्टिव एट, करेक्ट, एंड प्रेजेंस सर्वर जो आपके हैं उसमें स्टोर्ड होना चाहिए। तो यूजर ए आया, उससे आपने वेब सॉकेट कनेक्शन मेंटेन किया, जब भी आपने मेंटेन किया, स्टार्ट हुआ, हैंडशेक कंप्लीट हुआ, यू ऐड दैट एंट्री इन योर की वैल्यू स्टोर व्हिच इज योर प्रेजेंट सर्वर से होते हुए तो की वैल्यू स्टोर में आ जाएगा कि लास्ट एक्टिव वाज इस टाइम स्टैम्प पे था। दिस इज सिंपल, ठीक। तो एंड जब वो लॉग आउट करता है तो वो आप हटा दोगे कि लास्ट और लॉग आउट को उसने कर लिया था। अब आप बोलोगे कि लास्ट एक्टिव ऐड था, तो आपको आप मॉडिफाई कर सकते हो कि यूजर वो बैकग्राउंड में था नहीं था। आता है ना कि लाल स्टेटस, येलो स्टेटस, वो लेट्स से ब्लैक स्टेटस नहीं आता है। स्लैक अलग बिहेव करता है स्टेटस लेवल पे, व्हाट्सएप अलग बिहेव करता है। ऑनलाइन दिखाते लगातार याद है कि दिस यूजर इज ऑनलाइन, दिस मीन दिस गाय इज ऑन द व्हाट्सएप ऐप। द मोमेंट ही स्विचेस बैक और उसको बैकग्राउंड में डालता है तो वो हट जाता है ऑनलाइन, लास्ट सीन ऐड आ जाता है, सीन ऐड आ जाता है। तो कैसे आता है, वो लगातार जब भी वेब सॉकेट कनेक्शन मेंटेन होता है, जब तक वो एक्टिव है लगातार ये अपडेट हो रहा है टाइम स्टैम्प कि लास्ट सीन आ रही है, लास्ट सीन आ रही है, लास्ट सीन आ रही है, लास्ट सीन आ रही है।
तो ये बहुत ज्यादा नहीं हो जाएगा, मतलब अगर हर बार आप
तो कब अपडेट कर रहा है ये भी तो ना, वो अपडेट लॉग्ड आउट के टाइम पे करता है।
मतलब मेन हो गया एक बार इनिशियल लॉगिन तो मैं डेट हो गया
इनिशियल लास्ट सीन अपडेट होगा कि इसने एक्टिव कब, लास्ट इसने कब टाइम स्टैम्प क्रिएट किया, और लास्ट एक्टिव एट की लास्ट वैल्यू अपडेट कब करेगा वो, जब वो तुम लॉग आउट या फिर ऑफलाइन के इवेंट ट्रिगर करोगे, आपको बैकग्राउंड में ले गए, किल कर दिया, ये सब इवेंट आइडेंटिफाई करके तुम्हें सेंस एक और नया पैकेट सेंड किया जाता है और बोल दिया जाता है कि भाई बंदा अब ऑफलाइन है, तो उसका सीन ऐड आ जाता है फिर टाइम स्टैम्प पे। क्यों? क्योंकि वेब सॉकेट में तो कनेक्शन बना हुआ है आपका। हाँ मनीष बोलो।
और इसीलिए and that is why there is some delay in sometimes user getting offline versus receiver knowing that they have gone offline, because first that logout event or session end or app killed event will go, then it will be received by the these present server, and then it will be received by the people who are looking at that information. So there's always this delay of like a second or two as well, if you notice very carefully between this last seen or online dollar status.
हाँ, तो एक्चुअली ये थोड़ा डीप प्रॉब्लम है कि क्योंकि बिकॉज वी वर्क इन अ नॉन रिलायबल इंटरनेट वर्ल्ड करेंटली. इंटरनेट इज देयर बट इज नॉन रिलायबल इन टर्म्स ऑफ कम्युनिकेशन. और अगर if you are actually on WhatsApp app and your internet was down due to your memory choking, your core being slow, your actual Wi-Fi being slow for any reason, and if you are sending these events every single time, लगातार तुम्हारा ऑनलाइन ऑफलाइन स्विच हो रहा था, करेक्ट? Let's say तुम एक shoddy Wi-Fi में you were on a shoddy Wi-Fi like I was at the start of this session, correct? तो मेरा status बार-बार switch हो रहा था. तो what they do is client sends heartbeat कि I am alive, and based on that the status is updated, not based upon the triggers. So this trigger that you asked is basically कि after how much time do you actually have missed the heartbeat. Client keeps sending these heartbeat packages.
ये तो बहुत ज्यादा हेल्प नहीं हो जाएगा क्योंकि वर्ल्ड में इतना ज्यादा कस्टमर तो
पैकेट जाता है, एपीआई रिक्वेस्ट ही जाती है, बहुत पैकेट जाता है. देयर इज अ वेरी डिफरेंस बिटवीन पैकेट एंड एपीआई.
कोई ना कोई इसको रिसीव तो कर ही रहा होगा. तो पैक मतलब क्या डिफरेंस है बड़ा, मतलब आई अंडरस्टैंड कि देयर इज अ मैसेज बिटवीन पैकेट एंड लिटिल बिट. देयर इज अ सिंक्रोनस एंड देयर इज अ सिंक्रोनस.
बहुत डिफरेंस है मैसेज और एपीआई कॉल में.
And
पैकेट जा रहा है, एक हेल्थ चेक पैकेट जा रहा है.
Maybe similar to something like front end में जो हमारे events रेज होते हैं, right? वो भी तो ऐसे ही जाते होंगे.
लेकिन उसमें डिफरेंस ये है कि वो बैच होके इकट्ठा होके जाते हैं. जैसे हमारे अभी करंटली तो हम बहुत कॉन्करेंट बेचते हैं, दैट इज रॉन्ग, बट इवेंचुअली बैच होके जाएंगे. बट इमेजिन करो बैच हर 5 सेकंड पे चल रहा है या फिर हर 10 सेकंड पे चल रहा है. एंड ओनली इफ यू मिस 2 batches then you will say hey seen this seems like this user is offline. Then after you have missed the third batch, last receive heartbeat का टाइम दिखा दो. सिंपल है.
And there's one more thing that actually sending a message this small like this in 5 seconds is not too much, because if you think about it, even though if WhatsApp has like 1 billion active monthly users, at a particular point of time, at a particular minute, they might have, let's say, 1 lakh users. So 1 lakh into 12 messages a minute is not that much. Or maybe even if it's 1 million, it's not that much. So don't think of it like billion users ke supply zyada. Whenever they are online is only the time when it's getting sent. So everyone is not online at same point of time. Yeah, so that helps in terms of throughput.
So I just think there's a difference between whatever the event I didn't know about, but I know that there's a Kafka event, there's an analytics event which we have that I have seen in practical situation.
Event is still very heavy. Actual eventually सब पैकेट्स में जाता है, ठीक. इवेंचुअली सब एक रॉ लेवल HTTP TLS TCP या फिर UDP पैकेट्स में कन्वर्ट होकर जाता है सारी कम्युनिकेशन, ठीक है. जो भी तुम भेजते हो प्रोटोकॉल लेवल पे पैकेट्स में टूट के जाता है. मल्टीपल पार्ट्स में हेडर अलग से जाता है, एक्चुअली एपीआई अलग से जाती है, मल्टीपल पार्ट्स में मल्टीपल पैकेट्स आते हैं. दिस इज वन सिंगल पैकेट व्हिच इज वेरी लाइट.
Got it. So it's the maintaining, it's very easy also.
Very easy. And we actually, if you see our Grafana, see it, you will see there is a heartbeat package which is received by all our backend servers lagatar.
There's a VPN off, then this microservice starts saying there's a heartbeat for Kafka heartbeat. There's a consumer heartbeat. I think it's
this is heartbeat only. Now this is very trivial. What we have discussed. Health check jana jana for WhatsApp or become what is not trivial is how do you communicate this to all the users. This is where it comes, because if you remember we have presence servers, and when we were starting ki presence servers क्यों चाहिए अलग से, but you need independent servers because presence information which is critical for chat system, but it is very simple, it is business critical, but it needs to be related to all the users, correct? So user A will become let's say online or offline, it will have independent message queue. If you remember message queue was there, right? Presence server will also have presence independent message queues, and clients will work in pub/sub mode. If you're not active as a user, you don't need to receive that message, correct? You don't need to know if let's say Saurav Jajoria is not on the Up-sSkill call currently. He doesn't need to know what we are connecting, right? Ki call has extended by 30 minutes. It doesn't need to know, but you guys need to know if you are there. Similarly, if you are actually using WhatsApp right now and you are in that group or you are in that person's friend list, that right moment, only in that moment you need to know कि कौन online है कौन offline, not after that. So you will subscribe कि hey, I want to know everybody's presence that I'm currently talking to, and obviously presence servers can optimize कि hey, which group that you have last open, are you in one-on-one chat, all those business logic will be there. But this is how they're maintaining. If you are actually online, you will subscribe to hey, I want to know the queues, and you will be subscribed to various queues that you want to. You should be updated for. Cool. ये चमका नहीं चमका था, यूजर ए ने अपना स्टेटस अपडेट किया, करेक्ट, और देन इसके एक्चुअली सबके साथ वन-ऑन-वन क्यूज बने हुए, ए बी ए सी ए डी बना हुआ है. बी ने बोला कि मुझे ए के बारे में जानना है, सी ने बोला ए के बारे में जानना है, डी ने बोला ए के बारे में जानना है, एंड एट ओवरऑल लॉजिक लेवल इट विल बी हैपनिंग फॉर वेरियस यूजर्स कि बी भी फ्रेंड हो सकता है सी का, करेक्ट, तो ए सी को तो बी सी को भी सब्सक्राइब करेगा, बी डी को भी सब्सक्राइब करेगा बेस्ड अपॉन किसका फ्रेंड्स है, किस ग्रुप में है, व्हेनेवर दैट यूजर इज ऑनलाइन, not all the time. That's why it works on pub sub model कि आपको पब्लिश होगा, अगर आप सब्सक्राइब होगे इस पॉइंट ऑफ टाइम पे तभी आपको रिसीव होगा वेब सॉकेट के थ्रू ही, बिकॉज रियल टाइम हैंडशेक हो चुका है, उसके थ्रू ही आपको अपडेट हो जाएगा. Any questions till now, Manish?
No, no.
ऐड करना है आपको?
I think
Why there are multiple queues? मतलब एक ही क्यू में बस एक ही क्यू मेंटेन हो रही होती है, एक ही का
तुम्हें इस पर्टिकुलर यूजर से कनेक्शन है, तुम बिलियंस यूजर, देयर कैन बी बिलियंस यूजर्स, राइट, there are only 5 users in this call. If you are saying something, let's say, and your indication is, let's say, वो करो मुकुल, अभी वो कर दो, अपना वीडियो ऑफ कर दो, ऑन कर दो या ऑफ, जैसे मैंने अभी वीडियो ऑन कर दिया, करेक्ट, assume this me being online, या फिर and Mukul going offline, right? This has happened. Only people who are actually connected to Mukul and me, and there's a communication between me and Mukul ki my status needs to be updated to Manish, my status needs to be updated to Harsh, my status needs to be updated to you, and my status needs to be updated to Mukul. This is the communication layer that needs to happen. Similarly for Mukul also, Mukul's status needs to be updated for me, Manish, Harsh, and you, correct? And Saurav is not on this call. He doesn't care about all these communications. तो सौरभ का भी कनेक्शन मेंटेन होगा अगर ये 10 मिनट बाद ज्वाइन कर ले इस कॉल को, करेक्ट, देन ये स्टेटस उसको भी पता चलना पड़ेगा. दैट्स व्हाई ये ऑनलाइन है कि ऑफलाइन है, ये वन-ऑन-वन यूजर लेवल पे मेंटेन किया जाता है. और वो कब करना है, एंड यू आर एक्चुअली एलिजिबल फॉर इट और नॉट, यू सब्सक्राइब फॉर इट कि आई एम एक्चुअली यूजिंग व्हाट्सएप और फेसबुक मैसेंजर, आई एम इन वन-ऑन-वन चैट, कंटिन्यूअसली सेंड मी दिस गाइस स्टेटस, आई हैव मूव्ड आउट, I am in the group, don't send me status for various people. I'm in a group of various people, send me a congruent status of 3 or 4 people of this small group. This is business logic जो कि अलग-अलग प्लेटफॉर्म अपना लिख सकते हैं.
I got it, but the main point was how these are different queues were different because all of them contain the same data. Mean there's the AC and AD.
Same data नहीं है ना, अलग-अलग लोग को जाना है ना, ये कि A का स्टेटस B को अलग से जाना है तो एक पैकेट जाएगा उसको, करेक्ट, एक का स्टेटस सी को जाना तो उसका भी एक पैकेट जाएगा, एक का स्टेटस डी को जाना तो अलग से पैकेट जाएगा.
सिंगल क्यू की मतलब जो एक सिंगल क्यू में पैकेट्स पड़े होते कि मैं आई एम प्रेजेंट ऑन, वो
एक का स्टेटस जानना ही नहीं है ना, तुम्हें इसकी एंट्री जाननी ही नहीं है, तुम्हारी वो भी तो है, क्रॉस लिंकिंग भी तो है ना सोशल ग्राफ लेवल पे. तुम सी जैसे कनेक्टेड है ए से, लेकिन सी इज नॉट कनेक्टेड टू बी, तो अगर सी की अपडेट क्वेरी में चला जाएगा तो उसको फालतू स्टेटस भी मिल रहे होंगे. दैट्स व्हाई जिससे तुम किसी भी वे में कनेक्टेड हो उसी का स्टेटस जानना है. दैट्स व्हाई दे आर मेंटेनिंग वन चैनल फॉर ऑनलाइन स्टेटस फॉर वन सेट ऑफ डायरेक्ट नोड कनेक्शन फॉर यू.
गॉट इट. ओ सेम ही हो गया, मतलब आई थिंक अगर मैं माय पॉइंट वाज दैट कि एक ही सिंगल क्यू होती है जिसमें लोग सब्सक्राइब कर लेते हैं. आई वांट टू नो योर स्टेटस.
सब्सक्राइब ये तुम्हें यूजर लेवल पे करना पड़ता ना, तुम्हें सब्सक्राइब देन यूजर लेवल पे तुम से एक सिंगल क्यू रख सकते थे, लेकिन देन तुम्हें एक फिल्टर रखना पड़ता कि इन यूजर्स का ही भेजो मुझे. तुम्हें बहुत लोगों का अपडेट होना है, करेक्ट, तो देयर कैन बी व्हाट यू आर सेइंग इज राइट. यूजर बी कैन हैव हे आई एम सब्सक्राइबिंग टू ऑनलाइन स्टेटस ऑफ ऑल द पीपल आई एम कनेक्टेड टू, करेक्ट. देन इन दैट केस तुम्हें अपनी फ्रेंड लिस्ट पीछे रखनी पड़ती, मतलब पीछे तुम्हारी लगातार फिल्टरिंग होनी पड़ती है उस वाले से, वो लॉजिक रहना पड़ता है ना. क्यू तो बस बन गई तुम्हारे लिए,
जैसे कि एक डी ऑनलाइन गया तो क्यू डिलीट हो जाएगी, राइट. यू कैन से मैनेजमेंट वाज इजी.
यस, मैनेजमेंट इजी है ना उसकी. डिजाइन कॉल है ना ये कि मुझे चाहिए नहीं, उसको अपडेट ही नहीं करना है, क्यों मैनेज करना है मुझे, क्यों जिंदगी क्यों रखनी है, वो कॉस्ट मुझे पे ही नहीं करनी ना, मैं क्यों को अपडेट कर दूंगा.
And the other alternative, if Aman, you're thinking about that, could be like for user A, there's only one queue and everyone can subscribe to it. That does not work because messages, like these are ordered messages. So let's say user B got 2 messages, user C got 3 messages. So user B needs to see the third one and user C needs to see the fourth one. So there's a ordering defined. That is why each combination has their own set of queue. That is even true for the messages as well. Like the same philosophy is getting used here, that you can use a single queue. Even in a group, we could have used a single queue.
Yes. So this is clear now to you, Aman? Sorry, my internet is shoddy. I hope by design you're not seeing an offline status.
It's not just online, offline, Aman. It also shows you how at what time someone got offline, etc. Right? So, I know you're thinking that in messages, there at least messages could be different, but even in this, the messages could be online, online at 23:45, last seen 23:45, now online, right? So these are 3-4 messages, and like people can have different state. It's not just online, offline. If that was the case, then what you're saying would have worked definitely, I think.
Correct. So let me quickly summarize what we have learned today. We have set of requirements. We discuss how a traditional system should work. We learned why we'll not be using HTTP. Why we'll be using WebSocket. We learned why polling and long polling doesn't work, and why WebSocket suits for both the use case of sending and receiving. We learned there will be 3 parts of the system: some stateless, some stateful, and the third-party integrations. We learned the top-level design of how the system will maintain the 2 of the system together in one single instance per se. We learned what are the storage choices, why relational database will not be the right choice, and why various people use Edge-based Cassandra and all those key value store systems. We learned the system simple model of message and message ID driven from to and from, and for group message and channel ID, and deriving this information through a local ID or something like Snowflake could work. We learned that we need to keep a zookeeper because we will need to maintain a stateful system in terms of purely chat communication and storing those let's say WebSocket connections. In terms of overall design, we learned that there will be a message sync queue based upon what the person online or offline will either be sending directly the message or will be sending a push notification for later update. We learned how 2 devices, if user is using 2 devices, will store what was the last message maximum ID that the user has used on that device, and will maintain that, and will fetch that from data store and update the user in real time whenever he logs in from the other device. In a group chat, we learned that when you're sending a message to various people, they will be added in independent queues, and copy of message will be there, and from our design there will be one single message queue which is maintained where the WebSocket connection is maintained with that user. For online store, we learned that simple on and off packets will not work. Will need to send a heartbeat, and based upon the last status received of the heartbeat, we will update the last seen at status. We also learned that sending online status is not trivial as we deem to. You need to maintain a one-on-one or a user A to a many copies in some shape and form at your present servers, and people will subscribe to what they want to listen to. So that they are not bombarded with anything else, and they're not bombarded to status that they don't need. So this is what we have learned in chat system design. I hope we all have learned something. If there are no other questions, I guess that will be all for today.
Sure. Do we have a heartbeat case in UC? Do we have any implementation where we use heartbeat type of thing?
Independent.
Kafka,
हाँ.
I'll tell, like Kafka जो online रहता है हमारा, okay, कि Kafka down नहीं जा रहा है, and वो भी जो architecture maintain करता है, वो भी heartbeat send करता है अपने server को that I am online, और वो अपनी balancing करता है. So like if you go into the detail for the Kafka part, ना, you will understand कि like वो कैसे चल रहा है, like heartbeats.
But that was doing the Kafka, but do we have any explicit use in the app or something? We send the heartbeat to or something explicitly.
ये नहीं, we also have chat system design ना.
So I know. Do we send that of thing in the recent demo we have seen? Maybe.
We don't have our scale is not this much now. So even we don't need let's say very congruent information from the user. Online offline status of the first instance works well for us. Simple, when a user is actually opened the chat system, he's online. If he's closed the app, he's offline. Simple. eJabber on, and we use eJabber and all those solutions. They provide this level of configuration. When do you actually want to how frequent do you want to be? Those kind of solutions are there. So we use simple. Okay, user is has opened the app and has opened the chat system, he's online. Cool, guys. In that case, thanks for tuning in. See you for Up-sSkill session season 8 next week. Cheers. Take care.